These are the solutions to the quiz at the end of lesson 9.1. Now, number 1, the evidence that light is an electromagnetic wave is C. So, 2, we have green light and double slits. So we know that d sine theta equals m times lambda. Now, bringing the screen closer will mean that the fringes get closer together because the angle's staying the same, and y would get smaller as big D, distance to the screen, gets smaller. B, if the light is closer to the slits, there'll be no difference. C, if D was bigger and the other things were the same, then theta must be smaller, so spacing is decreasing. D has a larger wavelength will mean that theta is larger, so in fact D does lead to larger spacing. And finally, a smaller wavelength will be the opposite, so it would be fringes closer together. So D is the answer to that one. And number 3, the path length difference must be a whole number of wavelengths, and it's every whole number, so D is the answer. Now, number 4, we have m lambda equals d sine theta again, our double slit equation. We've got the second fringe, we've got then m is 2. Now, we have d is 50 microns, or 50 by 10 to the minus 6 meters. And we have theta is 1.22 degrees. So we get lambda equals d sine theta over 2. 50 by 10 to the minus 6, sine of 1.22, and we have a 2. And that gives us 532 nanometers. Now, number 5, for a dark fringe, we have d sine theta equals m plus a half times lambda. When m is 0, we have d sine theta is just a half a wavelength. So sine of theta naught is lambda over 2d, whereas for m equals 1, we have sine of theta 1 is 1.5 times lambda over d. So we have 3 lambda over 2d. Now, sine theta 1 over sine of theta 0 is just 3 lambda over 2d over 1 lambda over 2d, which is 3. So sine of theta 1 for the m is 1 is 3 times sine of theta 0, which is 3 times sine of 15, and that is 0.776. So theta 1 is 51 degrees. You notice sine isn't a linear function. We couldn't just multiply 15 by 3. Now, number 6, we have the m equals 7. So again, d sine theta equals m lambda. Now we know that tan of theta is y over d, which is 0.025 over 1.1, which is 0.02273, and that gives us theta is about 1.302 degrees. So sine theta is 0.023. So then we have d, which is 1.4 by 10 to the minus 4 times 0.023 equals 7 lambda. So lambda is 1.4 by 10 to the minus 4 times 0.023 over 7, which is 4.6 by 10 to the minus 7 meters, or 460 nanometers. Now, question 7, we've got the double slit here and we've got a screen. Now, we are interested, if that's the M is 0, we're interested in the spacing between any two slits. So basically, we're saying that the delta M is 1. So we have lambda equals 589 nanometers. We want the angle for M equals 1 is 0.2 degrees. So sine theta equals sine of 0.2, 0.0035. Then d sine theta equals lambda. So d equals lambda over sine theta, which is 589 by 10 to the minus 9 over 0.0035, which is 1.69 by 10 to the minus 4 meters, or 169 microns. And 8, we have d equals 0.18 millimeters. Distance to the screen, 80 centimeters, or 0.8 meters. Lambda is 656 nanometers. We want to find the intensity at y equals 0.6 meters. So we're going to use the equation that has y rather than theta. So it's I naught cos squared pi d over lambda big D times y. And we're using radians. So I over I naught is, because we want the fraction, it is cos squared pi little d over lambda big D times y, which is cos squared pi times 0.18 by 10 to the minus 3 over 656 by 10 to the minus 9 times 0.8 times 0.6 by 10 to the minus 2, which gives you cos squared 6.465, and that is cos of 6.465 is 0.9835, but it's squared. So that is 0.967. That is how much of the maximum intensity you get at that point.